coming up with values, and they give you different types of equations. Well, one is logarithm, and I mean, there's hyperbolic. There's all kinds of equations or setups for equations that allows you to use y equals mx plus b. They've all been modified to resemble y equals mx plus b. Well, they just don't show you. They can say, I'll do it for you. Just sit here, put yourself down. Done. But this is how it's done. Let's do one more. Let's take a look at problem number 51. Problem number 51. You got this ethyl chloride thing. So here's the equation they give us. And this decomposes, much like Mozart. C2H4 gas plus HCl gas. And this is a first order reaction, which is nice to know, because we haven't studied the second one. So let's put down the information we do know, shall we? Okay. So the initial concentration of ethyl chloride, so CH3, CH2Cl, in brackets, sub 0, is 0.00100 moles per liter. We really should put a space in there. After heating at 500 degrees Celsius. Well, since our equation didn't have anything about temperature, this is called chemical bookkeeping, making sure they got everything taken care of logistically. It has nothing to do with the problem. What it does say next is important, and that is the time for that is 155 seconds. And that was, the concentration for this then is reduced. So I'll put CH3, CH2Cl. But since this is at 155 seconds, and this is at 0 seconds, I'm going to put a sub 155, which doesn't really factor into the whole logarithm thing, but it's there to identify because we've got a third time and a third concentration that we're going to have to solve for. So let's put this value, this concentration in, and it says 0.000 67 moles per liter. Really should put that space in there. And then what is the concentration of ethyl chloride after 256 seconds? So T equals 256 seconds, and they want to know what is the concentration CH3, CH2, Cl, sub 256. Yes or unknown? Now, in order to solve this problem, we got to figure out something's missing here. What's missing? They give us two scenarios and say this is what it is, and then based upon that, we got to find a concentration at a third time. We got to find that relationship that allows us to do that. So let's write the equation that we're supposed to use for these scenarios, and that is concentration of A, or natural log of the concentration of A is equal to negative KT plus the natural log of A sub 0. And I'll put A sub T right here. Since we're dealing with all these different times here, I'll put T there to emphasize that. What was never given to us in these problems? In this problem, we have all these scenarios, 3 scenarios. What was not given to us? Well, they gave us the original concentration. That's not an issue. They gave you the concentration of A in two of the 3, or 2 scenarios actually. This is actually combined the A sub 0 and 155 in the same scenario. So there's 2 scenarios here. They gave us the time for each of those scenarios. They didn't give us K. We got to solve for K somewhere. Well, we go back to the beginning, And if we just use these numbers right here for the equation and plug that in right here, so that means that this 0.11 blah 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 is right there. This 155 seconds is right there. The concentration of A at 155 is 0.0067. That goes right there. We can use our mathematical skills to figure out K. Then we can go back and use this equation again. And now we still know the original, we don't know the 256 concentration. And so that's the plan of attack we're going to take here, okay? So, let's do that, shall we? All right. So, natural log of, what's the value for 155? 0.0067 equals negative K, we don't know K, we established that, but the time there was 155 seconds. Plus the natural log of the original concentration of A, which is, use parentheses here because we're not specific to the concentration, 0.001. Okay, so here's our unknown right here. So we're going to get, we're going to rewrite that as negative 155K. Find the natural log of 0.001. I get negative 6 point, I'm going to go 3 decimal places again. Negative 6.908. And the natural log of 0.0067 gives me negative 7.308. So now we have just a goofy looking simple algebra problem. You got decimals and big numbers and dogs and cats living together. So let's move this over here by adding positive 6.908. And that, oh, that's a rather clean number there. That's kind of clean. Instead of getting rid of 3 digits clean, this is a negative 0.4 equals negative 155K. So we divide both sides by the negative 155, we get K by itself. And rather conveniently, as we would expect, value of K is going to be positive. We take 0.4 and divide by this rate of 155. I already got rid of the negative sign. I get 0.00258 moles per liter. Putting my space properly in there. And that's moles per liter. Oh, now this is a first order reaction, isn't it? So that's not right. That's not a concentration. First order reaction, the exponents for the constant has to add up to -1. And you always have to have an S in there, so this is going to be S to the -1. So there's your label for K in a first order reaction. Now we go back to that equation. Natural log of the concentration of A sub T equals negative KT plus the natural log of A sub 0. And now we plug in what we got in the second scenario. Well, we do know the value of this is actually 0.001001. And we calculated that already, so let's just go ahead and punch that thing in there. What did we say that was? Negative 6.908. Minus 6.908 for that one. And we got K now is 0.00258, and it's a negative sign, negative 0.00258. Seconds to -1. times the time. Now the time in the second scenario is 256 seconds, yes. Oh no, I hate it when that happens. By the way, I hate this smart board. I'm going to retire in 4 years. This is a gift from a parent, and I really appreciate the gift. I love the smart board in theory. This one is possessed. The devil lives in this thing. When I retire, I'm going to take this, just whip it right out of the wall, take it to the cornfield right over here. I got a hammer. I'm going to smash to death a la Casino. If you've not seen the movie Casino, watch it, and then you'll understand what I mean. I'm tired of it. Anyway, hi. Times the time, 256 seconds. And that'll equal to the natural log of the concentration of A at 256. Probably can't read that to them. That's a -1 for the F's. So we have -0.00258 times 256 minus 6.908. And I get a negative 7.568. Again, I'm going 3 decimal places until I get to the final answer, then I'll go to 3 figs. This is the natural log of A sub 256. Again, I got natural log and not log, so I've got to get rid of the exponent. So if I take the e caret and a base of e caret on both sides, it does get rid of my exponent because logarithm is exponent. And so the concentration of A at 256 seconds is, with second E negative 7.568, and we have 5.17 times 10 to the -4, and this is the concentration, so that's moles per liter, or if you like, zeros, which I have to test, 0.00517 moles per liter. You're gonna write it like that, you're gonna put your stinking space in there, I'm gonna pretend like you don't hit. You forgot to put an answer in. Okay. So, your assignment then, you're going to be doing the even number problems 50 and 52. This is 41, 51. Yeah, 41. Problems again, 50 and 52.